So hi, hello and welcome, Oliver here, and welcome to the Microbehunter Microscopy podcast, where I also, among other things, answer the question of some of my viewers. And today I received another question, and unfortunately I'm not able to respond by email because the email is always returned. So sometimes there is indeed some kind of an emailing problem. And for this reason, I would like to answer the question now in the form of a little bit of a voice message here. So what I'll do is I'll read out the question to you. It's about mounting of specimens, and then let's have a closer look here. And the question is as follows. I'm new to microscopy and just discovered your channels, which have been very helpful and inspiring. Thank you. I was wondering if it's possible to make permanent slides of aquatic creatures like diatoms and vorticella, etc. I've searched for info but haven't found anything yet. Interested to know how they could be mounted and preserved. Well, first of all, thank you very much for your question. And yes, it is possible, of course, to make permanent mounts of these organisms. However, diatoms and vorticella and other ciliates, it's quite different to be treated. First of all, diatoms, these are microorganisms that have a silica shell. So the silica that's chemically similar to glass, and these microbes, these shells are quite easily mountable. The reason is that they do not change their shape and they do not shrink when you mount them. The silica shell is quite robust, quite rigid. Of course, the cell's contents, this can be removed and often is removed, but then the diatom shells themselves, they actually look quite nice, and these are actually very favorite and very common specimens to be mounted. Now, when you mount diatoms, and you do not, let's say that you only want to mount the shells and you're not interested so much in mounting the whole cell contents as well, then you have to remove the cell's contents by treating it with hot hydrogen peroxide. Be extremely careful. It is a very aggressive substance, and the hydrogen peroxide will oxidize everything that is organic. Now, silica, the shell, is not organic, and therefore it will not be broken down, but the cell's contents and all other impurities that can be found in the sample will be removed. Well, not all impurities, but the organic impurities at least. And after you've treated it, the diatom sample, usually it's some kind of diatomaceous earth or some sediment that you find from on the ground of a pond. And afterwards, after you've removed all of the organic substances, you want to remove the H2O2, the hydrogen peroxide, by washing and centrifuging the sample and then adding some acid, for example, vinegar. And this will remove now all carbonates. For example, little sand, some sand grains that might be carbonates, the shells of certain mollusks. These are all carbonates, and they can all be removed by treatment with acid. Essentially, the carbonates, the calcium carbonate, will be converted to carbon dioxide gas, and it will bubble out of your little test tube. And what you have left over are hopefully more or less pure diatom shells, and they can then be mounted. And generally, the mounting media that you can be quite flexible in choosing the mounting media, because those diatom shells themselves, they do not shrink when you treat them with alcohol or with any solvent, which is a very common part in a mounting medium. The refractive index should be relatively high of the mounting medium, so that the diatom shells essentially can be seen quite well. If you do a little bit of research, you will find that several people have tried out different mounting media for diatoms. And there are some of them that are commonly used. Now, other microorganisms, other water microorganisms, like you mentioned, vorticella, and that would also include other ciliates here, are significantly more difficult to mount. And one of the reasons is that because they don't have a shell, they are very sensitive to water loss, and they will deform quite easily. So this is essentially a problem. Because many mounting media do contain solvents, alcohol, maybe sometimes in the case of Uperol, it's not really alcohol, but it's miscible with alcohol, and certain resin containing mounting media, many of them contain actually toxic substances like xylene, but this is a very hydrophobic substance, and the specimen must be completely dry. So what you have to do is you have to take the water microorganisms and add increasingly high concentrations of alcohol to carefully remove the water. And this process, if not done carefully, can cause the microorganisms to shrink a lot and cause artifacts. And for this reason, delicate water microorganisms like certain algae and ciliates, like you mentioned over here, cannot be mounted in mounting media that contain organic solvents, because they simply will deform too much. And what you use in this case is you use a water-based mounting medium, for example, glycerin gelatin, or also known as glycerol jelly, which is a mounting medium which does not completely turn solid, and it is water-based. And it's a very difficult to use mounting medium, as a matter of fact, because you have to warm it up, and then it will become liquid, and then you're able to mount the specimen. However, if you make it too hot, then the gelatin is going to break, and it's never going to solidify in the first place. So you have to be very careful, and also that there's the danger of bubbles being formed. At least it likes to form bubbles quite easily. So it's a difficult mounting medium to work with, but it's water-based, and because it does not turn completely solid, the water microorganisms will also not lose their shape too much. The problem is that this mounting medium is not allowed to dry out completely. It remains in a semi-solid state. And this causes a few problems. Well, first of all, there is the problem of humidity, and that because water can evaporate and can also enter the specimen because the small edge where the cover glass on the side. And the second problem is because it does not turn completely solid. Glycerin gelatin it must be physically stabilized, the cover glass, that is, because the glycerin gelatin is not able to hold the cover glass in place very well, and at least not for long-term preservation. And for this reason, you need to put a ring around the cover glass. Usually people use nail polish to do that. So it's called sealing the cover glass, and this is actually one of the reasons why many or some microscope slides have this black ring around them, because this kind of holds the cover glass in place and also prevents an exchange of moisture. So you see that not all water microorganisms are the same. Diatoms are relatively easy to prepare. Just let them dry essentially, and then you put some mounting medium on top. And if the cell's contents shrink, well, then so be it. But the shell at least stays. And Vorticella and other water organisms and certain algae that don't have a shell, they're quite sensitive to shrinkage and might deform quite a bit. So what I would say is the best way to learn this is by experimentation, of course. And different people essentially have different favorite mounting media for the different microorganisms that you would like to mount. So I encourage you that you do a little bit of research maybe, and then you're going to soon discover that people have tried all different types of mounting media, especially with the diatoms. Nafrax, I think, is one of them. It's been commonly used, but there are also others as well. Well, in any case, I think that for right now, I'm just going to call it quits again. I wish you all the best. Happy microbe hunting as always, and see you around next time. Bye-bye.